Welcome to Quintessence, the study of inner worlds. On this show, we will examine the science of stories and experiences. We will explore movies, games, science, psychology, programming, and other topics. In this first episode, I want to ask a simple question. How do we store experience? The more times we repeat a task over and over again, the better we get at doing it. What is going on? I'm not going to focus on what is physically happening in the brain. Instead, I'm interested in how an everyday experience can be broken down into reusable information, and how something similar could be done by a computer. In an attempt to answer that question, I created this simulation. What you are seeing is two players running around a maze. The blue dot is being controlled by a human being, and the yellow dot is a computer program. As the human player walks the blue dot around the map, every move they make is used to train the yellow computer player. Right now, both dots are overlapping at the start, and none of them are moving. This is because the blue human player hasn't made any moves yet, and so the yellow computer player doesn't know how to move. Now the blue is moving down, and the yellow is also able to move down. Since down is the only direction the yellow knows how to do, it keeps moving downward forever. Then the blue moves up and to the right. Instantly, the yellow learns this trick too, and begins using it. Notice how the blue hasn't moved left yet, and as a result the yellow still doesn't know how to do it either. The longer the blue walks around, the smarter the yellow gets, and the better it gets at staying on the path. The system is surprisingly good at picking up on subtlety. In this example, the player is moving back and forth on one corner of the map. The computer soon wanders over and begins doing the same mindless back and forth behavior, not knowing why, just knowing that it must be important. Here the simulation has been restarted, and the blue is now walking only on the red tiles. After a little while, the yellow figures out this trick too, and begins trying to only walk on the red tiles. So what is going on? How is the computer learning from the human? You may have noticed the blue squares around both players. These squares represent their vision. They can't see the entire maze at once, only the 9 tiles nearest to them. Every time the blue moves, all of the tiles around it are recorded. Red tiles are recorded as 1s, and white tiles are recorded as 0s. These 1s and 0s are then put together in a list. Additionally, the previous move made by the player is also recorded as a number between 0 and 3, corresponding to a different direction. The current move the player is making is also added. This list of numbers is then added as one entry into another list of moves the player has made before. When the computer player wants to move to a new tile, it starts by scanning all of the tiles around it and making a list of numbers. It then adds what its previous move was. Finally, it takes this information and looks through the list of human moves to find the one most similar. It then chooses its next move based on what the human did. To put it more simply, every time the human player moves, their choice and the context for that choice are recorded. Then, the computer uses its current context to figure out what to do based on what the human did. In this simulation, I have basically broken down the knowledge into the form of if statements and then statements. The if is the context and the then is the next move. I believe that this is the fundamental building block of all knowledge and experience. The reason we are better at doing a task on the 100th try than we are on the first is because we have accumulated a long list of if-thens to draw from. This system isn't perfect. In this example, I'm trying to teach the computer how to move in circles around the red square. I move around sometimes clockwise and sometimes counterclockwise. When the computer tries this, it can't decide whether to do one or the other, so it ends up trying to do both at the same time. In this case, what the computer needs is a way to separate clockwise movement and counterclockwise movement. Or in other words, it needs to store its knowledge hierarchically. Maybe I'll do a video on that in the future. Anyway, this is Quintessence.